Hello my dear students, we have seen the explanation of polynomials and solved some of the problems in R.S. Agarwal class 9 textbook. In this video we are going to see the factor theorem. This theorem is there in R.D. Sharma book of 9th class and also Karnataka state textbook of 9th standard. Before going into the statement of factor theorem, let us first try to understand it. Many people try to memorize the formulas and theorems, but without the proper understanding of how they have been derived or what they really mean, it is very difficult to solve higher order thinking problems. First, let us see what is a factor. We all know that. Let me take a number 24 and divide it by 4. We get 6 as the quotient and 0 as the remainder. Means 24 is fully divisible by 4, meaning remainder is 0 when 4 is the factor of 24. Same applies to the polynomials. I have taken a polynomial here. Let us try to divide it by x plus 2. So here x plus 2, we see it is x cube and here we have x. So if we multiply by x square, we will have x into x, x cube plus 2x square. Now change the sign and subtract it, we get x square and plus 5x. Here we see x square and here x, so I will do x multiply by x, x square plus 2x. Now change the sign and add it. We are subtracting it, so we are getting 3x plus 6. Again we have plus 3, we get 3x plus 6. When we subtract, the remainder becomes 0. We know that dividend is equal to divider into quotient plus remainder. So if I denote this as p of x and this as the quotient q of x, then I will get dividend, that is we have denoted as p of x, is equal to divisor, that is x plus 2, and quotient we have put as q of x and the remainder r. We have seen remainder in this case is 0, so we will just say p of x is equal to x plus 2 q of x in this case. So when we express p of x as a multiple of these two, we can say x plus 2 is a factor of p of x. Because we got the remainder 0, x plus 2 has fully divided p of x, giving the quotient q of x. Now after getting this, let us say we will make x is equal to minus 2. Then this will become minus 2 plus 2 and this whole thing will become 0. If x is equal to minus 2, this thing will become 0. What will happen to p of x if we write x is equal to minus 2? So p of minus 2 will become minus 2 cube plus 3 into minus 2 square plus 5 into minus 2 plus 6. This will be minus 8 plus 12 minus 10 plus 6. So this will become minus 18 plus 18, which will give us 0. This means that for x value minus 2, we have p of minus 2 giving 0, making this whole statement true. So if I change this minus 2 here to a, this plus 2 I will denote as minus of minus 2. So this becomes x minus a. So we have p of x is equal to x minus a into q of x is the generalization for this. Now p of a becomes a minus a into q of a minus a becoming 0, this whole thing becomes 0. This means for p of a, x minus a becomes a factor. So the theorem states that if p of a is equal to 0, then x minus a is a factor of p of x, and the converse of this, that is, if x minus a is a factor, then p of a is equal to 0. This is the factor theorem. Let us see some problems related to this. Now I am writing an algebraic expression x square minus 5x plus 6. Let me call it f of x. Now if we factorize this using the splitting of middle term, we get x square minus 3x minus 2x plus 6. This is equal to x minus 3 minus 2 into x minus 3, x minus 3 into x minus 2 is the factorization of this f of x. Now let's try to apply this factor theorem to this and see if it works. So here we have x minus 3 as one factor and x minus 2 as one factor. Let us take, we know from the factor theorem that if x minus a is a factor, then f of a should be equal to 0. So let us try to apply a as 3 and see if f of 3 becomes 0. Here 3 square minus 5 into 3 plus 6, this is equal to 9 minus 15 plus 6 is equal to minus 15 plus 15 is equal to 0. So f of 3 is 0. Similarly, we will see if f of 2 is also 0, because x minus 2 is also a factor. So 2 square minus 5 into 2 plus 6 is equal to 4 minus 10 plus 6, that is minus 10 plus 10 is equal to 0. Again f of 2 is equal to 0. So our factor theorem is applied here and we see that it is true. A multiple choice question in R.S. Agarwal Mathematics 9 page number 337 asks, what is the value of k if x plus 1 is a factor of the polynomial 2x square plus kx. So here x plus 1 to be a factor, we know that x minus a is a factor if f of a is equal to 0. So here let's denote f of x as 2x square plus kx, and in this form a's value becomes minus 1 because here it is plus 1. So f of minus 1 should be equal to 0, which implies, so f of minus 1, that is 2 into minus 1 square plus k into minus 1 should be equal to 0. This is 2 minus 1k equal to 0 implies k equal to 2. Page 36, exercise 2.3 of Karnataka State Mathematics 9 textbook part 1 says, if p of x is equal to x cube minus 4x square plus x plus 6, then if g of x is equal to x minus 3, examine if g of x is a factor of p of x. it is straightforward. Here x minus a form we have, so a is equal to 3. So if g of x has to be a factor of p of x, we have to have p of 3 should be equal to 0. So p of 3 equal to prove p of 3 is equal to 3 cube minus 4 into 3 square plus 3 plus 6. This is equal to 27, 36 plus 3 plus 6 is equal to 36 minus 36. Addition of these is equal to 0. So we get p of 3 is equal to 0. That is why g of x is a factor of p of x. All these examples we have seen are giving the remainder 0. What if the remainder was non-zero? Say, like if I divide 25 by 4, we get 24 and 1 as the remainder. We don't call 4 a factor of 5 because it doesn't fully divide it. So here we have 1. Here in this case we have dividend equal to divisor into quotient plus the remainder. This remainder becomes non-zero. In the same problem, what if I had not 6 but 7 here? When we have 7 here, we get 7 here and remainder won't be 0, it will be 1. So this is R. In this case, our p of x, x cube plus 3x square plus 5x plus 7 is equal to x plus 2, that is the divisor, into the quotient plus 1. This is the remainder. Here when we take p of minus 2, like the previous case, we get minus 2 cube plus 3 into minus 2 square plus 5 into minus 2 plus 7, that is equal to 8 minus 8 plus 12 minus 10 plus 7, which is equal to minus 18 plus 19, giving 1, which is the same as our remainder R. If we do the same generalization, taking this as x minus a, we get p of x is equal to x minus a into q of x plus the remainder r of x, let's say, which is actually r because the remainder is always less than the divisor, and in this case it can be either 0 or a constant term. So here we get p of x is equal to x minus a into q of x plus the remainder r. When we take p of a, we get a minus a into q of x plus r. This becomes 0 plus r. So p of a becomes the remainder. That is why we can say that p of x is equal to x minus a into q of x plus p of a, means if we divide p of x by some x minus a, we get p of a as the remainder. This is the remainder theorem of polynomials. Here we have a problem. Find the remainder when p of x is this algebraic expression divided by x minus 1. We know that p of x is equal to x minus a into q q of x plus p of a. Here this is the remainder. We have to find what is p of a. X minus 1 implies we have a is equal to 1. So p of a is equal to p of 1. So p of 1 is equal to 1 power 4 minus 3 into 1 square plus 2 into 1 plus 1, that is equal to 1 minus 3 plus 2 plus 1, which is equal to 4 minus 3, that is 1. Therefore remainder is 1. In this video, we tried to understand the factor theorem and remainder theorem and solved some of the problems. If you found this video helpful, please subscribe to the channel. Love Maths.